All right, so this is the second part of 9.7 marginal analysis. And what we're going to do is we're going to look at average cost, average profit, average revenue. It all means the same thing. And then we're going to transition to marginal average of cost, marginal average of profit, and marginal average of revenue. So whatever we do with the cost function or marginal cost, we can do it with the profit and the revenue. That's the bottom line for this. So when you think about average values, if I were to ask you to find the average test scores, so let's say you had 3 tests, and let's say your tests were 78%, 92%, and an 80%. In order to find the average of those, you would add these values up. So I end up with 80, 90, 180, 250, and divide it by 3. Let me double check, get my calculator. I'm trying to do it in my head. It's not always a good call. So 78 plus 92 plus 80. Look at me, 250 divided by 3. Now, when you divide by 3, you're dividing by the number of numbers, okay? The number of items. We had 3 tests, we're dividing by the number of tests. So when you divide by 3, you have an average of 83 1/3%. Okay, that's how you find average. Well, with cost, profit, and revenue, it really is the same concept. All you're going to do is you're going to take, in this case, the cost function, and you're just going to divide it by the number of items. Well, what's the number of items? Well, in this cost function, the x represents the number of items. That's how many items we're producing in order to run our business. So with a cost function, all you're going to do is you're going to divide the whole thing by x. Now what this does is it gives you an average cost. An average, you show average by putting a bar over the variable. So this is how you know you have an average cost, okay? Or an average profit, you'd put a bar over the P. Average revenue, you'd put a bar over the R. So now I can simplify this. Remember, when you're dividing the whole thing by x, you end up with 20,000 divided by x plus 10x divided by x. Well, when I simplify this, you can see that here I can cancel my x's. Here I can write this as 20,000 x. If I bring it to the top, it becomes a negative exponent. Okay, so you can write it this way, this is fine, or you can write it with a negative exponent. Because the exponent was on the bottom and I brought it to the top, it becomes a -1. Okay, so there's our average cost. All right, now we can plug values in and find out, okay, well, what does it cost me on average, overall, that's what average is, overall, in general, how much does it cost me to produce a certain one? So the average cost per unit, we're finding if we had 1,000 dictionaries. So this is our dictionary cost function. All we're going to do is we're going to find the average cost of 1,000 dictionaries. We're going to plug in our values. I'm getting a little bit, let me move this down a little so you can actually see it. Okay, so average cost of 1,000 dictionaries. So we're going to go 20,000 times 1,000 raised to the -1 plus 10. So remember, you can also do this way, right? -1 means that when I drop it, it becomes a positive. So we have 20,000 divided by 1,000 gives us 20 plus 10. So we end up with an average cost of 1,000 products is $30, or 1,000 dictionaries is about $30. That's the average cost for the dictionaries. Okay, so that's average cost. Then what we're going to do is we're going to take this average cost function and we're going to find the marginal average. In other words, how much is my cost changing from one unit of measure to the next, or one unit, like the 900th and the 1,000th to the 1,000th. We can find how much is our cost changing. So here's our cost function. Let me rewrite all these. So our cost function was 20,000 plus 10x. Our average cost function was 20,000 x to the negative 1 plus 10. And now we want to find our marginal average. So if you notice, marginal average, I just added a tick mark. Okay? The average is the bar, and then the tick mark shows that we're looking for the derivative. So we're going to use our power rule. We're going to drop our negative 1 to the front, and we get negative 20,000 x. Remember, we are subtracting 1. So negative 1 plus a negative 1 is a negative 2. And then the 10 is a constant, so that just drops to 0. Our derivative is 0. Okay, so here is a marginal average cost. Now, if we want to know what does the marginal average cost at 1,000 units, now we're going to use this one. So we have marginal average cost of 1,000 units. We plug 1,000 in anytime we see an x. The other way that you can write this, if this is not comfortable for you, right? So it was negative on top. We drop it to the bottom. It becomes a positive. So we're going to do negative 20,000 divided by 1,000 squared, and we get negative 0.02. All right, now interpret that. Remember, math is great, and most people, once you get the process, you go, okay, this isn't too bad. It's just a matter of knowing when do I multiply, divide, whatever it is, order of operations. But then you got to be able to interpret your answer. When you're working with word problems, which you're going to do a lot in this class, you have to be able to interpret your answer. So remember, what we found, we were looking at the marginal average cost. Okay, so marginal means derivative. You have to remember that. Marginal and derivative mean the same thing. Derivative is how much things change. All right, the rate of change. So when it's negative, when I have a negative derivative, that means my change is decreasing. It's going down. So when I'm looking at the marginal average, what this says is my cost when I am producing 1,000 products is decreasing by 2 cents per product. Okay? Every product I make, the cost is decreasing. And that's how you interpret it. All right?